Now let's talk about other problems that relate to percent composition. What is the ratio of atoms in order of magnesium, oxygen, and hydrogen? And of course, if we look at again the MgOH or magnesium hydroxide, and for magnesium we have only one, of course, so 1 Mg, and for oxygen we distributed, and that gave us 2 oxygen. And then for hydrogen, again, we distributed the number outside the parenthesis. That gave us 2 hydrogen again. So the ratio in terms of atoms is 1:2:2. And that's it. Why don't we care about the 3? That 3 is irrelevant because we just need to focus on one single molecule or one single compound. And another problem that relates to percent composition is, what is the ratios of moles in order of magnesium, oxygen, and hydrogen? And of course we look at the chemical formula for our magnesium hydroxide again. We have 1 magnesium, so just 1 moles of magnesium, and oxygen is being distributed by the 2 outside the parenthesis. That gave us 2 moles of oxygen, same lot. And the same thing for hydrogen, we would have 2 moles for hydrogen as well. And that's all we have to do for this problem. And another problem that deals with ratio is that, what is the ratio of mass in order of magnesium, oxygen, and hydrogen? And of course we figured out the percentage in here, right? And this is percentage by mass, which is relative to 100. So what if we assume that this sample is out of 100? And of course if we look at percentage for magnesium, for oxygen, and hydrogen, we can actually express this as a ratio, which with the assumption that it is out of 100. So we can say that assume out of 100 grams, with this assumption out of 100 grams, we can express this as in terms of grams. So we would have 41.7 grams colon 54.9 grams colon and 3.46 grams. And that's all we have to do if we were to express this in terms of mass. This is 41.7 grams of magnesium, this is 54.9 grams of oxygen, and this is 3.46 grams of hydrogen. And that is the ratios in terms of grams, with the assumption that is out of 100 grams. Now let's try some of the most complicated problem. For example, in a sample of 10 grams of magnesium hydroxide is diluted in a solution of 1.5 liter of distilled water. How many grams of magnesium hydroxide are in the solution? There are 2 ways to solve this problem. First of all, if we look at percentage of magnesium in magnesium hydroxide, we have 41.7%, or in relative term out of 1, we have 0.417. So of course, going back to the ideas of percentage, if we know the percentage of composition, we can apply this to the entire sample, which is 10 grams. So all we have to do is look at in terms of percentage. So let's look at percentage. First of all, this is a pie chart, which is out of 100%. And if we look at this in terms of percentage, 41.7% is magnesium. Now, this whole entire sample is, of course, is 10 grams. So how is percentage related to the sample as a whole? When you have percentage of a whole, all you have to do is multiply in terms of decimal 0.417, in this case because we have 41.7%, times the total of the sample, and that would give you in terms of whatever unit we are looking for. Specifically in this case it is a gram. So this right here is equal to 4.17 grams, where the whole entire thing is equal to 10.0 grams. You see how that works? So what does that tell you? Of course, we can now find directly using percentage to solve for a gram of magnesium. And that's all we have to do for that problem. But if we look at another way of solving this, notice how we have gram of magnesium hydroxide, which is MgOH2, and we're looking for grams of magnesium in magnesium hydroxide. We can use our stoichiometry flowchart, going from our given, which is 10 grams of magnesium hydroxide, to question mark grams of magnesium, which is mass A to mass B. So let's look at the work. Of course, I have 10.0 gram of magnesium hydroxide times the molar mass of magnesium hydroxide so that the grams of magnesium hydroxide cancel out. We're following our flowchart here. And if you need help with the flowchart, go back and review the other videos. So notice how the gram of magnesium hydroxide cancel out, give us mole, and of course this is the mole ratio coming directly from the chemical formulas itself. We have 1 magnesium in the compound of magnesium hydroxide. That's where this 1 is coming from. Moles of magnesium hydroxide cancel out, then give us moles of magnesium, and of course we can look at the molar mass of magnesium hydroxide, which is the mole going to be on the bottom to cancel out with moles of magnesium, and the mass is 24.31. And if we plug this into our calculator, everything on the top multiply each other, divide everything on the bottom, give us 4.17 grams, and that is the exact number as that one. And this is the exact answer as the other methods using percentage. Let's look at another example. A sample of 10 grams of magnesium hydroxide is again the same scenario, but we are looking for how many moles of magnesium are in the solution. Assume this problem wasn't given to us and we are given this problem directly. Of course, we would use the knowledge of percentage again. Magnesium is 41% in the compound, and we take that and we multiply to the entire sample in decimal form, give us the mass of magnesium. But we're looking for mole of magnesium. Of course, we are going to multiply by the molar mass using our stoichiometry flowchart. From mass to mole is molar mass, or 1 moles of A equal to the number of grams of A. In this case, the grams on the bottom, so gram of magnesium cancel out, and we plug this into our calculator, give us 0.1715 moles of magnesium. And if we look at stoichiometry flowchart, starting from our given 10 grams of magnesium hydroxide, which is mass of A, okay, and we go into moles of B because the chemical is now changed, we look at the work, starting with our given 10 grams of magnesium hydroxide time our first conversion factor, the gram is on the bottom, and of course the gram of magnesium hydroxide. Notice how the gram of magnesium hydroxide cancel out, give us moles of magnesium hydroxide, and again we look at the mole ratio within the chemical formula, 1 moles of magnesium in this entire compound, and moles of magnesium hydroxide cancel out. And then what we have here, or simplified to 1, if we use a fancy term for math. So in this case we have our number, and we multiply everything on top, divide everything on the bottom, give us 0.1714 moles of magnesium. You see how close that is? So the method is still valid. Okay? Lastly, let's try one of the hardest problem of them all. Is that we're looking for, again, the same scenario. We have 10 grams of magnesium hydroxide being diluted in 1.5 liter of distilled water. How many hydroxide ions are in the solution? Of course, we can solve 2 different ways. One using the percentage, which is presented here. Again, percentage of magnesium is 41.7% or 0.417, and we take that times the entire sample, which is 10 grams, give us our mass of magnesium. Again, we are looking for ions, so we have to convert our mass all the way to represent a particle, which include the ions in it. So grams times the molar mass, which the mass cancel out to give us mole of magnesium hydroxide. And again, if you are struggling with this, go back to the video on solving problem with stoichiometry. Okay, and the moles of magnesium cancel out, give us moles of hydroxide. And where do I get this mole ratio from? Go back to magnesium hydroxide over here. Notice how this is hydroxide and this is magnesium. And if we look at this as in terms of magnesium, how many magnesium do we have? 1. And how many hydroxide do we have? 2, because of that 2 right there. As simple as that. And of course, mole of magnesium cancel out, give us mole of hydroxide. And then lastly, we use the Avogadro number based on our stoichiometry flowchart. The moles of hydroxide cancel out, give us ions of hydroxide. And if we plug this into our calculator, of course, we have this right here. 2.07 times 10 to the 23rd hydroxide ions. And if we look at the stoichiometry way, we will start from our given, which is 10 grams of magnesium hydroxide, and we are solving for ions of hydroxide, which is going from mass of A all the way to represented particles of B. So we have again 10 grams of magnesium hydroxide times the first conversion factor, and the grams on the bottom because we need to cancel each other out, and this is coming from the periodic table. This two cancel out or simplify. And then we have moles of magnesium hydroxide that's going to be simplified or cancel out with this mole of magnesium hydroxide. And again, where do I get this mole ratio from? Look at magnesium hydroxide. See that 2 right there? That tells you there are 2 moles of magnesium hydroxide in one of this compound. And that's where I get the 2 from. And if I continue, this is just the Avogadro number relative to moles of hydroxide. And 6.02 times 10 to the 23rd hydroxide ions. And if we plug this into our calculator, of course, this answer is going to be the same as that answer. Now do you see the beauty of percentage and how it can simplify or trick us in a problem?